Hello guys and gals, and welcome to a new tutorial. In this video we're going to be covering a conveyor belt system that will push objects or our player in the desired direction and the desired speed. So you can see here it's pushing all these lovely objects along, and it will also push our player if we wanted to. If we go into the faster one, if we were to run against the flow, you can see that it's still pushing our character, so he has a harder time getting to the opposite end. These are going to be fully customizable, so you can set these to any speed and any color that you want. So say we change this guy up, we can say we want him to be green. Maybe we want this guy to be pink, and perhaps this guy's a little bit too slow, so we'll just increase his speed, like so. And then if we were to press play, you see that will affect the object as well. Whee! It's a violent conveyor belt, oh my. Now you are going to need a couple of assets, one being a texture and one being a static mesh that I've prepared for you. There will be a link in the description so that you can download these. And as always, if you are on my Patreon, you'll be able to just download the project files directly, so you don't have to sit through this tutorial. You can just download the assets and use them as you please. So let's begin. The first thing what we're going to make is going to be the blueprint. We're just going to delete these out of our world. We'll right click, blueprint class, actor, and we will call this conveyor underscore BP. And we'll open this up and we'll add a component, and the first thing that we're going to add in is our static mesh. So we'll just select static mesh, and then under our static mesh we're just going to find our conveyor. Now we can either search for it, I think we called it conveyor static mesh, we did, or we can head to where it is in our folders and just drag it directly in, like so. Now you'll notice it's a little bit stumpier than the one that I had in the example, and that's because the example was scaled on the X to 2, so it was a little bit longer. So how are we going to actually use our conveyor? We are going to be checking for objects that are within a specific range, and then we're going to push them. To do this, we're going to need a box collision. So add component, box collision, and once that's in, we're just going to scale them up. We want it to encapsulate pretty much the entire conveyor belt, but not the edges. The edges aren't technically moving, they're just a little rim. So we're just going to check in the top view here and just align this like so. We'll have a little bit of overlap on the ends, just so that it makes communicating between two different conveyor belts, if you wanted that to happen, a little bit easier. We'll switch back to our perspective mode, and now we're just going to raise our box up, like so. There we are. We'll compile. Now we'll head to our event graph, and we're going to start working on the blueprint logic. We're not going to use a begin play or overlap, but we are going to be using tick. Now tick is going to fire the logic every single frame, so if your game is running at 120 frames a second, it's going to run this logic 120 times per second. Similarly, if you're running at 10 frames per second, this is only going to happen 10 times per second. Normally you want to avoid using event tick, especially for super large amounts of logic, but for something very small like this, it's going to be fine. And as long as we don't have like a million of these in our scene, it's not going to affect your performance at all. It's just going to be all lovely jubbly. So, as we've already said, we know that we are going to be using our box collision, so we'll drag this in. And we're going to be looking at anything that's currently within the box. So we'll drag off from box, and we will get overlapping actors, and this is going to give us an array. Now an array is just a list of objects. In this case, it's going to give us a list of anything that's currently overlapping with our box. We're not going to use a class filter, we're just going to leave this blank because we want to check for everything. To get things from our little list here, we're going to use a for each loop, and what this is going to do is it's going to allow us to get everything in this list and then run this logic per every item within that array. We're going to plug the event tick directly into the execute pin, and then we're going to have to start setting up how to move the objects. The first thing that we're going to need is a variable, so we'll add a variable, and we're going to call this speed, and we're going to set this to a float, which is a numeric value with a decimal point, and we will compile this and give it a default value of maybe 250, like so. And we're just going to take this little eyeball icon here to expose our variable so that we can change this in the editor and make them all different, like you saw in the example at the start. There we are. So now we'll press compile again. Now we have speed, and that's saved into there. But how are we going to use this? Well, we're already using event tick. We're going to be moving things based on the delta seconds. and we're going to be using our speed. So we'll drag speed out and we'll get speed. And from delta seconds, we will multiply by another float, because these are both float values. You can see both light green. We'll plug the speed in like so. Now this is going to give us delta seconds times by our speed. And that's going to determine how quickly we move our objects. But so far we don't know where we're going to be moving these objects to. So what we're going to do is we're going to check the current direction that our conveyor belt is facing, and then we're going to push the objects in that direction, because we're going to push our objects along the conveyor belt. So we'll drag out from our static mesh, like so, and then what we'll do is we'll get world rotation, so that we can check which way our object is rotated, and then we will get our forward vector to get the forward direction based on our rotation. So we'll quickly compile so I can explain this. We can put our blueprint down. In fact, this will be slightly easier to explain if we just go into our viewport, select our default scene route, and we're just going to add an arrow component and raise it up. Now you can see that this arrow is pointing in a specific direction. This is forward in relation to our blueprint. So by getting the world rotation here, you see here we've got forward, which is defaulted onto our X axis. If we were to rotate this, obviously our forward arrow is going to change, and so is our forward vector. So we're going to be using our world rotation, say here, to get which way forward is currently facing. So we've got the forward vector. What are we going to do with this? Well, we need to take this, and then to get a location out of this, as this is a vector which has 3 coordinates x, y, and z, we're just going to multiply this, multiply, by a float. And we can plug our previous multiplication into the new one. And this is how we're going to move the objects. From array element, because remember we're moving things from within the list, we're just going to add actor world offset. And this will allow us to push our actor in the world based on our multiplication. That there should push our objects around, but there is going to be a bit of a problem. If we press play, we're probably going to see that it pushes the conveyor belt. As you can see there, it just slides away. Bye-bye, conveyor belt. It was lovely to see you. See you next time. Bye-bye. And the reason that this is happening is because our conveyor belt, by default, is, well, it's within our get actors, our overlapping actors. So we're going to select our static mesh, and then we are just going to turn off generate overlap events under collision. Compile, close this down, press play. Now it won't move, but if we were to move our character onto it, our character will get pushed. Yay! Similarly, if we were to just move this across really quick, so it's above our objects will also get pushed. Now you're going to find when you put some cubes in here to test this out, your cubes won't fall, so let's just delete these real quick, like so. And we'll put a cube in here. You'll see that your cube doesn't do anything. Oh no, poor cube. Oops. So what you need to do is turn on simulate physics, and again, if we press play, it will just fall, nothing will happen. And the reason being is because the opposite of our conveyor belt, this isn't overlapping. It's not generating overlap events by default. So we're just going to scroll down to collision and turn that on. And if we press play, it will push it along as soon as it's within range. Yay! So it's pushing, it's doing all of its loveliness. Now we're just going to make it look a little bit sexier, okay? So what we're going to do, right click, new material, and we'll call this Conveyor _M, and we'll open this up. And inside of our Conveyor M, we're just going to drag in our conveyor mask, like so. And because this is a mask, we're going to be changing this inside of our blueprints to whatever we want it to be. To do this, we're going to need a 3 vector, so we're going to hold V on our keyboard and click. And we'll get a vector parameter here. And we're going to call this color. And we're going to set this to the lovely default of yellow. Which is 1 in the red and 1 in the green. And then we will hold M and left click for a multiply. And we'll multiply our texture by our color. And what this is going to do, as our texture is a mask with white and black, white being a value of 1 and black being a value of 0, is going to multiply 1, 1, 0, 0 by 1 and 0 for our texture. Anything that is 1 or white will change into the color that we multiply it by, and the black will stay the same because black has a value of 0, and if you were to multiply 0 by anything, you're going to get 0. So there we have our lovely color. We're just going to hold M and left click again for a multiply, and this is going to go into our emissive. But we need some emissive value. We can plug our color straight into here like so. We'll hold S and left click and we'll call this glow intensity. And we'll set this to perhaps 5 and plug this in. This is just going to take our color values and multiply them by 5 so that we get a nice glow on our emissive. Then what we need to do is we need to make our arrows move. We're not going to actually move the mesh. We're going to be animating our texture so that it's our texture that moves. To do this, we'll use a panner. So hold P and left click for a panner, and we'll plug this into our UVs. And now we need to just split some values apart. We have a coordinates pin, which will give us our X and our Y coordinates, and we have a speed pin, which give us our X and our Y in the speed. To change these so that we can have multiple arrows without them being stretched, because right now if we were to put this on our conveyor, we would only have 2 arrows across the entire thing, which isn't going to look too great. We are going to hold a U and left click for a texture coordinate, which is essentially the default U and V, which is 1 on the U and 1 on the V. We will hold M and left click for a multiply, like so. And we can plug this into our coordinate, but we only want to change the X value so that we only get more arrows. We don't want more arrows above arrows because we'll have like a strange wavy line. So what we'll do is we'll hold S and left click and we'll call this X scale, like so, and then we'll just hold 1 and left click and just put 1 in there because we don't need to change the Y. Then what we'll do is we will append, and what an append vector will do is it will take the values, in this case 0 and 1, we're just going to default this to 1, our values 1 and 1, and it will place them into a singular list as if they were one value, and it's going to then go into multiply them. So 1 and 1 are going to get multiplied by 1 and 1. I know that doesn't seem like it's doing anything because technically it's not, but we'll be able to change this inside of our blueprint a little bit later. So now that we have our scale changeable, we need our speed changeable, and our speed we're going to do pretty much exactly the same way. We're just going to hold S and left click, speed X. In fact, if we call it X speed, so we have the same naming convention, and then we have one called Y speed. We're probably not ever going to change the Y, but we'll just call it Y speed for now. We're going to default this to minus 0.2 by default. And then again, we just want to append the vector, and then we'll plug this into speed, and that will only move the X. So we should see that our lovely arrows start moving to the right. There we are. So we're going to press apply, and then we'll close this down. Now what we can do is we can open up our conveyor static mesh here, and with our nice new material that we've just created, we're going to drag that and drop that into slot number 1. You can see because of the way I've set the UVs up, we're just going to already have our arrows going the right way. And you can see here we're only getting 2 arrows ever at a time, but it's working the way we need. For our second slot, we're just going to give this a regular base color. So we'll just right click, not blueprint, right click, material. We'll just call this base underscore M, and you can just put any old color you want in here. We'll open this up, hold 3 and left click. I'm just going to plug black in, and we'll press apply. Head back over, drop a base in there, and then when that catches up, that will turn black. So now we have our material on here, but it's not quite doing what we want it to. As you can see, we've only got 2 arrows. So what we're going to do is open our blueprint back up, and now we're going to mess around with it a little bit. So what we will do is we will head to the construct script, and this is going to allow us to change our values inside of the editor and see them immediately without having to press play to test them. So with our construct script here, what we will do is we'll drag out our static mesh, and we know that our lovely moving arrows are in slot 1 if we select our mesh. You can see here, well, element 0 because arrays start at 0. We have our moving material in element 0, we will drag out from static mesh. We will create a dynamic material instance from element index 0. We're just going to drag our conveyor material into the source material here. Then we will drag from our static mesh and we will set material in element 0 again to our new material here. But then we're actually going to change some things around. So we'll drag out from the dynamic material instance. And because this is a dynamic material instance, we can change any of the variables that we previously set up, like our vector. So we will set a vector parameter value, which we called color. I believe we called it color. Let's just double check. I have no reason to have called it anything else. Yep, color. And we can then set color to anything we want to. But rather than just setting it directly in here, what we're going to do is right click value, promote this to a variable, and we'll call this color. We'll compile, and now you'll notice that we just have black on our blueprint. The reason we just have black is because our default color here is black. We will expose the variable so that we can change it the same way we will with our speed. We'll select the color and we'll just give it back its default of yellow, like so. You can see now this has gone yellow. If we press compile, we can test this out. We can select the blueprint. And with the blueprint selected, we can then click our color because we've exposed it, and we can change this in real time. So we can set this to whatever we want. Let's go with a green, like so. Now we'll open the blueprint back up because we also need to change our scale. So we have, I believe, X scale. Yep. So we're going to drag out from our return value from the create dynamic material instance. I'm just tripping over my own tongue. Oh my gosh. We'll set, this was a scalar parameter value because it was only a singular digit. There we are. And this is called X scale, like so. If we press compile, we'll probably see that these arrows will disappear, or they'll turn into one long blobby mess. And here, any value that we plug in will be the scale. So 1 is going to give us 2 arrows, 2 will give us 4 arrows, and so on. Again, we'll right click the value and promote it to variable, and we're just going to call this arrow scales. And we'll expose this. I'm just going to set this to 3, as I found that was quite a nice amount of arrows there. So you can see now we're getting our lovely little arrows. Yay! And the one last thing that we need to do is change our X speed, which is the same as what we've just done, a scalar parameter value. So we'll just copy this and paste it. And we will change our parameter name from X scale to X speed. We will promote the variable. Oops. We will compile. We're going to get an error because we haven't plugged anything into the target. We'll call this our track speed. And we'll give this a default of -0.4. And then just make sure that we plug our dynamic material instance into the target and compile. And now, if we were to change our track speed to maybe -0.1, it will go a lot faster there. And we'll set this to, no, 250. I think 250 pretty much matches. Yeah. A slight amount of offset there, as you can see, but you just have to fine tune these numbers just so you can get the pushing of the character to match the arrows on the floor. There we go. You can see it's working all nice and lovely. And we can go ahead and just make some more of these little things here. Maybe we'll rotate some around. Scale this guy a little bit more. Take another conveyor belt, just rotate it around. And line them up like so. So they can overlap one another. There we are. And maybe this guy, I want it to go super fast at 500. -2 for our track speed. Change it to, oh no, let's go with a pink. Change it to a pink. Play, and then we can see our boxes get pushed along. Or our character, because our character is also overlapping. Whee! When you land on a physics object, you get some weird results. There you go. But there you go, guys. A really cool little conveyor belt for you, fully customizable to however you want it to be. And for those of you wondering, if you were to rotate this upwards, it will still work. Whee! As you can see. Whee! Nice. So there you go. A really cool little conveyor belt system. Hopefully some of you will find that useful. Hopefully some of you have learned something new in this tutorial. But there you are. As always, you will find links to my Twitter, my Discord, and the Patreon in the description below. Thank you very much for watching. I'll see you all next time. Bye bye.